Okay, guys, in this video, we are going to take a look at the standard unit vectors, I, j, and k, and their properties as it relates to the cross product. So the first thing I want you to remember is just like when we draw x-axis, right? And then we draw the y-axis like this way, and then we would draw the z-axis which way? Like this, right? Start over here and draw it like that. So imagine that this is vector I, right? Which is length of 1. Then this is vector j, length of 1, and its direction is the same as the positive y-axis. And then this is vector k. Now imagine going from I to j to k in a counterclockwise way. So like this. So it turns out that there are special properties, and that is that if I cross I with j, I get k. So as long as you're moving counterclockwise, right? You're going from I to j, then to k. So I cross j is k. Then if you start at j, go to k. This is supposed to be j. That'll give you I, right? So j cross with k is I. And then you can also do k cross with I equal j. So in a question, I can ask you to compute something, but I'm going to say you cannot use the definition of the cross product, which is like one big determinant where you write out your rows and all of that. That's not what we want. Here we want these properties. So just using these properties only. Now, what if it's a different order? What if I wanted to find j cross with I? Well, is that going to be the same thing? Well, no. Remember property of the cross product that you actually have to reverse the sign. So this is actually going to be minus k. This one is going to be k cross with j. That would be negative I. And finally, I cross with k would be negative j. So it's not that hard to figure this out. So you just draw the little picture and you immediately see which way it goes. If you're going counterclockwise, then it's positive. If you're going clockwise, then it's negative. Also, you need to know that if you cross a vector with itself, that is always going to be a zero vector. That comes out of the properties of determinant. If you have the same or even proportionate rows or columns, the determinant is zero. So you can show that, it's not hard, that you're going to get exactly the same. And then when you subtract, that the answer will be zero. So j cross with j is zero, and also k cross with k is zero. Okay, so that's also zero. Now let's use that to answer the following questions. So for example, I cross with I, well, that's zero. In my open math, you can't put an arrow on top, but that's okay. I cross with j, so I already have that here, that's k. I cross with k, well, I have k cross with I, that's j, but I cross with k is negative j, so this would be minus j. J cross with k is I. Okay, so that's going to help us figure this out. So let's see if we can figure this one out. So we have negative 9 multiplied by I cross I. Well, that's 0. Okay, minus 2 multiplied by ij, that I cross with j, that's k, plus I cross with k, well, that was negative j, and then plus 6j with k, that's I. Okay, so now we just have to arrange it in the order that we usually do. We want to put I first, so this is going to be 6I minus j minus 2k. And again, we can verify that, but in this case, we just want to only use the properties of the standard unit vector. So let me just submit that, make sure that's correct. Okay, so now we have one more thing, and that is take this new vector that you got, because we just figured this out. So we got 6I minus j minus 2k. And we want to cross that with I. Now we have a distributive property of the cross product, so we can distribute this, but you have to keep the same order, because remember that cross product is not commutative. So you're going to have 6 I cross with I minus j cross with I in that order minus 2k cross with I. Okay, what is I cross with I? Well, it's just going to be 0 vector. Then j cross with I, well, that was negative k, right? So this is going to be negative k. And then k cross I, well, that's j. So this is going to be negative 2j. Final answer, negative 2j plus k. So let's see if that's right. All right.